Just going to mention at the outset that this video is really only intended for students of A-level mathematics, because ordinarily in statistics I'd need to justify my choice of this method, but in A-level mathematics this isn't required. Now, suppose we know the mean and the standard deviation of some complete set of items. We describe this as the population mean and standard deviation. For example, a particular machine manufactures bolts that are normally distributed with a mean diameter of 5.8 millimeters and a standard deviation of 0.15 millimeters. Now, suppose a customer receives a batch of bolts purporting to be from this particular machine. And from this batch, they take a random sample of 50 bolts and find the sample mean of these 50 bolts is 5.84 millimeters. This sample mean is larger than expected, but is it so much larger that we can say these bolts must have been produced by a machine with a population mean that is in fact larger than 5.8 millimeters? Well, we'll carry out a hypothesis test to decide this. So to recap, finding our sample has a mean of 5.84 millimeters leads us to suspect that the population mean is larger than 5.8 millimeters. This could come about, for example, because we believe the machine that manufactures the bolts has drifted out of tolerance and is making larger bolts. The null hypothesis is that the population mean is indeed 5.8 millimeters as claimed. The alternative hypothesis is that the population mean is larger than 5.8 millimeters. So this will be a one-tailed test, and to be clear, it's the upper tail we're considering because we suspect the mean is larger. Let's say our significance level is 5%. Then, if the probability associated with our sample mean is smaller than 5%, it's too small a probability for us to find believable, and we would reject the null hypothesis. But how do we find the probability of our sample mean? Well, there's a formula we can use to find the probability. Well, not the probability, but rather the Z value. However, your calculator will easily convert the Z value to a probability. X bar is the sample mean. Mu is the population mean. Sigma is the standard deviation. And N is the number of samples. So now we've got our value of Z. Now, you must be absolutely clear in your mind that to convert Z into a probability, you use the standard normal distribution. What makes it standard is that it has a mean of 0 and a standard deviation of 1. Our Z of 1.8856 is around here. Now, because we're concerned the mean may be too large, it's the upper region we are interested in. Now we'll convert that Z value to a probability using our calculator. Be very clear, when converting a Z value to probability, we always have a mean of 0 and standard deviation of 1. And in this case, the lower bound of the area we're seeking is 1.8856, and we'll make the upper bound so large the calculator will give us an accurate answer. So let's call this upper bound 10,000. So we'll press menu 7 for distribution. We'll choose a normal continuous distribution. Now we said the lower value was 1.8856, and we chose 10,000 as the upper. Our standard deviation is set to 1 already, and our mean is 0, so we're good to go. So our calculator gives us the value 0.0297. This is less than our significance level. So we reject the null hypothesis. There is sufficient evidence to believe that the population mean is greater than 5.8 millimeters. So we have reason to believe the machine is manufacturing larger bolts. And there we have it. If you found this video useful, then please like it and do subscribe to the channel.